under the bright skies. Only sunshine under the bright skies.
Good morning, my friend. We are talking about auto sensor, which is named also the Lambda sensor. At the late of 17th century, appeared a problem of ozone as a result of heat and gas emission. So the auto manufacturers are forced to find a solution of emission. So they was controlling the amount of by amount of the fuel and the air into the combustion chamber engine. From this device, auto sensor, which controlled by PCM, where the measuring signal up 0.45 volt, it means that the mixture is rich and the PCM reduce the pulse width to injector to reduce fuel.
So today I'm going to be talking about the difference between having a rich and a lean mixture and the air to fuel ratio. Having a rich mixture basically consists of having too much fuel and not enough air, and then having a lean mixture is having too much air and not enough fuel.
Hello guys, today we are here at El Camino's Automotive Technology Program. I'm David, and today we will be talking about O2 sensors. Automotive oxygen sensors, known as O2 sensors, make electronic fuel injection and emission control possible. They help determine in real time if the air-fuel ratio of a combustion engine is rich or lean. The sensor does not actually measure oxygen concentration, but rather the difference between the amount of oxygen in the exhaust gas and the amount of oxygen in air. Rich mixture causes an oxygen demand. This demand causes a voltage to build up due to the transportation of oxygen ions through the sensor layer. Lean mixture causes low voltage since there is an oxygen excess. Above me is this 1998 Honda Prelude. Here we have our pre and our post O2 sensor. Today we will be diagnosing these O2 sensors and see what kind of readings we get. Let's do this. With me is my friend and classmate Edgar. He will be teaching us how to diagnose an O2 sensor. Edgar?
This is the process of getting to the information on how to read an oxygen sensor. We're going to read the upstream. So we're going to go to scan diagnostic. For this vehicle, we're going to go to global OBD2. Remember, the vehicle has to be on for this thing to function. Okay, so now we're gonna head over to data stream mode 1. This thing has to load. There you go. And we're looking for our oxygen sensors. And here we found the upstream oxygen sensor. Now we want to graph this. We want to put graph and let it run for a little bit. That way we can get more data on it. And then for testing procedures, we will freeze this. We take one frame, let's say from here. So if I want to start here, we'll do an entire frame starting from there. Alright guys, right now we're going to test an oxygen sensor. We're doing the upstream. So basically what we're checking for is voltage signals have to be at a certain point So what we're gonna do right now is check. As you can see here, we want to move the dot over, the period over 1, 2, 3, so it'll be 170 volts. Right now it's set in voltage, and what we want to check is millivolts. So right now is 170 volts. I'm going to make a tally. 1, 260 volts, 730 volts, 860 volts,
You guys ain't gonna need these.
800 volts, 690 volts, 480, that would be the middle, 280 volts, 250 volts, 690 volts, 860 volts, 820 volts, 711 volts, 530 volts, and 260 volts, and finally 170 volts. Now what all this means is that anything on the opposite sides is good. The more voltage you have on the right side and on the left side is better. That equals a good oxygen sensor. See, notice how I have very little tallies, very little voltage signals coming from the middle. If I had more in the middle than any other place on the sides, more voltage or less, that would mean I would have a bad oxygen sensor. So basically that's how you check an oxygen sensor upstream using a scan tool.
Alright, today I'm going to be talking about the wideband oxygen sensor, the differences between the original oxygen sensor and a wideband oxygen sensor. So the main difference is basically the air to fuel ratio. In a wideband oxygen sensor, it's more accurate compared to the oxygen sensor. Oxygen sensor only tests the leanness and the richness between, or the difference between 14.7 to 1 ratio. Where it says wideband oxygen sensor, it tests all the way as rich as 10 to 1 ratio and as lean as 23 to 1 ratio. Most vehicles nowadays, they do require more accurate air to fuel ratio. Like the vehicle on top of us we have today is a 2001 Toyota Tacoma Pre-Runner. A little bit of history about the wideband oxygen sensor is the first manufacturer that was used was Honda back in 1992.
Good.
So what we have right here is the schematic of the wideband oxygen sensor on this 2001 Toyota Tacoma Pre-Runner. We have a waveform viewer right here already hooked up to our oxygen, the wideband oxygen sensor right here. It's connected to ground right here. Basically what we're trying to do is find the readings for the oxygen sensor on this wideband oxygen sensor. What we're trying to do is make sure we have some kind of supply of voltage in the signal wiring. Then what we did right here is we just compared the fuel to air ratio to the sensor voltage ratio.
Bruh.
Automotive oxygen sensors, known as O2 sensors, bro, is rich or lean. The sensor does not actually measure. Hello guys, today we are here at El Camino College. And,
All right.
got it. Ready, set, go. Hello guys, today we are at Hello guys, today we at our
Them bricks is way too high, you need to cut it.
Alright, so what we have right here today is a 2001 Toyota Pre-Runner Tacoma. Like any other vehicle, there is two oxygen sensors, also known as a broadband oxygen sensor, a wide range oxygen sensor, air to fuel ratio sensor, wide range.
If the O2 sensor signal down points increase, to increase the fuel at the combustion. Switch is incorrect. Increase to increase the fuel at the emission.